Hello, it's Dr. Daystorms, and I just wanted to do a video where we go through and work some more examples of balancing chemical equations. So let's go ahead and get started. The first example I want to do is where we're going to react potassium metal with water to form potassium hydroxide and hydrogen gas. One of the very first things that I like to do is make what I call the RP chart, which is for reactants and products. We have K, H, and O. I usually start with putting down all of the reactants and all of the products. So remember, according to the law of conservation of mass, we cannot create or destroy matter. And so, therefore, we're going to have one potassium as a reactant. We have a total of 2 hydrogens and 1 oxygen. And on the product side, we have 1 potassium, 1 oxygen, and 3 hydrogens. So the only thing out of balance right now are the number of hydrogens. Well, the only item that we have on the reactant side that contains hydrogens is water. So therefore, we start with just really using trial and error. And we're going to put 2 down in front of the water. So that's going to change this to where we now have a total of 4 hydrogens and 2 oxygens, but the potassium remains unchanged. So how can we balance the oxygens on the product side? Well, we can balance those by putting a 2 in front of potassium hydroxide. That means now we're going to have 2 potassiums, 2 oxygens, and a total of 4 hydrogens on the products. So if we now notice, the only thing out of balance is this number of potassiums. So if we put a 2 in front of the potassium there, that's going to change this to 2. So now everything is balanced. So it's 2 potassium metals plus 2 molar equivalents of water to form 2 potassium hydroxides and hydrogen gas. Let's do another example. This time, we're actually going to start off with tetraphosphorus decoxide. So it's tetraphosphorus decoxide plus water to form phosphoric acid. So we want to make our RP chart for phosphorus, hydrogen, and oxygen. Okay. We already know right off the bat we have 4 here of the phosphorus and only 1 on that side. We have a total of 11 oxygens, only 4 on that side. And we have a total of 2 hydrogens and 3 hydrogens on that side. So we know right off the bat we have to balance off those phosphoruses, and we can do that by putting a 4 right there. That immediately changes our numbers. So now instead of 3, we actually have 12 hydrogens. We do have our 4 phosphoruses, and we've got 16 oxygens. So now both the oxygens and the hydrogens are out of balance. So let's try to balance those hydrogens. So if we look, a common thing is that if we just multiply the reactant side of hydrogens by 6, it will make 12. So let's try that. So now this gives us 12 hydrogens, and we're going to have 10 oxygens plus 6 oxygens makes 16. So now this is all equal. It's 1 tetraphosphorus decoxide plus 6 waters go on to make 4 molar equivalents of phosphoric acid. Let's do one final example. And this is the combustion of methane gas. So in the combustion of methane gas, we have, methane gas plus oxygen. The combustion of hydrocarbons gives off carbon dioxide and water. Let's make our RP chart. Reactants, products, C, H, O. We have 1 carbon, 4 hydrogens, 2 oxygens. We have 1 carbon, 2 hydrogens, and 3 oxygens. So let's first try to balance out the hydrogens. So if we put a 2 coefficient in front of the water, this will now give us a total of 4 hydrogens and 4 oxygens. So the only thing out of balance now is the number of oxygens. So if we put a 2 in front of the elemental oxygen here, we're going to end up with 4, and everything is balanced. We have 1 molar equivalent of methane gas reacts with 2 molar equivalents of oxygen to form carbon dioxide and 2 molar equivalents of water. Hopefully this is giving you some practice. There are lots of examples at the back of your book, or the back of the chapter of your book, and I suggest that you just keep doing these until you feel comfortable doing them. I'll see you in class.